A Scientific Revolution by Francis Watts. Part 1. Let There Be Light. Quote, after one has played a vast quantity of notes and more notes, it is simplicity that emerges as the crowning reward of art. And that is by Frederic Chopin. All right. I've never been much of a religious or spiritual person. I've always put my faith in rational thought and the science that comes from it. However, it is based upon my own rational thought that I've decided I no longer believe in theoretical physics. This is considered a radical statement in today's world. However, let me explain, because my reasons are not complicated. Quite the opposite, they are simple. The entire field of knowledge, known as physics, exists to explain the world around us that we observe and experience. Today, this field of knowledge is divided in two halves, classical physics and theoretical physics. From the very beginning, the entire universe to the very small, the smallest quantum particle, everything is explained with the combination of these two halves. This split in physics may seem immutable in our individual minds today, but it did not always exist. It was created, and not that long ago. The term classical physics was first used early in the 20th century, about 100 years ago. It was a term invented to differentiate the new trendy theories of the 20th century from the older, well-established theories of the previous 19th century. The split in physics seems permanent to us, but little more than 100 years ago, there was no such thing as theoretical physics. And classical physics was just called physics. There was no split. These terms used to delineate between two halves of modern physics do not acknowledge the significant difference between the two. Yes, classical physics is comprised of theories created before the 20th century, and theoretical physics is technically just theory rather than fact. But that is not the significant difference. Classical theories are about physical things and physical forces. Theoretical theories are about immaterial things and immaterial forces. Physics is split in two halves. One half explains our physical world in physical terms. The other half explains our immaterial world in immaterial terms. This huge split in physics happened for a very simple reason that involves something very basic in all our lives: light. Light is not some abstract concept. It is what we see with our own two eyes. It fills our world and surrounds us. It is primarily through light that we have come to understand the world around us. What we understand light to be plays a role in how we understand light to move. And how we understand light to move determines how we come to understand everything we observe through light. Because our knowledge of the world comes primarily through light, this is no small thing. According to theoretical physics, according to today's theoretical physics, the light that we see with our own eyes is explained in terms of particles that then possess a quality called particle-wave duality. According to this concept, when light is observed to be a wave, it is not because light is a wave, it is because light is illusionary. When light is observed to be a wave, it is only imagined to be an abstract, immaterial wave. At the end of the 19th century, however, according to physics, this was before the split, light was explained more simply in terms of physical waves alone. Nothing that was observed to be true about light at the time was explained in terms of particles. Observations of light were explained in terms of waves, so therefore light is a wave. We are taught to believe in the 20th century particle theory dogmatically today, and this older 19th century understanding of light is mostly forgotten. It gets mentioned in our history books, but its significance is not. These two theories don't just exist, they are part of a conflict that spans most of recorded human history. Particle and wave theories of light can be traced back to ancient Greek philosophers over 2,000 years ago. Conflict raged over these two theories during the birth of modern physics over 400 years ago, and it continued until the 20th century, about 100 years ago, ending with this new particle understanding of light. This huge split in physics can be explained in terms of a basic observation of light that we all see with our own eyes but give little thought to. The reason when we look into a mirror we see our own reflection is because light passes through itself. We see our own reflection in mirrors because light bouncing off our own faces travels to the mirror, bounces off the mirror, and then hits our eyes. In that process, light is passing through itself. It is traveling through the same space, but in opposite directions simultaneously. It is this basic observation of light, used to explain how mirrors work, that creates the entire split in modern physics. Light doesn't just pass through itself with mirrors throughout space and all the time. Light is always passing through itself, going and coming in all directions simultaneously. In the early days of modern physics, light was first understood in more general terms as a force that moves through space. The question debated was, how does that force move? In classical physics, there are only two ways in which physical forces move through space: through the motion of physical waves or the motion of physical objects, particles. In the beginning, both particle and wave theories of light were attempts to explain light in physical terms. While there are aspects of light's observed motion that can be explained in terms of particles, how light passes through itself cannot be explained by particles because that's not something particles do. That's only something waves do. Waves move through space and bounce off surfaces just like particles, but they also pass through each other. If light is a wave, it remains a physical explanation. If light is a particle, it is no longer a physical explanation because physical particles cannot pass through each other. Therefore, light, if it is a particle, must be immaterial. This difference in explanation behind how light passes through itself and how mirrors work puts light as a wave in the category of classical physics, not just because it is a 19th century theory, because it understood light to be a physical force. Light as a particle is part of theoretical physics because it is about an immaterial particle. The theory that light is a particle rather than a wave isn't just part of theoretical physics. It was the first theoretical theory in the 20th century to be created. The rest of theoretical physics didn't just come later, it is all based upon this first theory. Early in the 20th century, immaterial light particles were called quanta, and today quantum mechanics explains light and all the other immaterial particles that have been discovered since. Scientific knowledge is like architecture. One thing is built upon another. A house is built upon a foundation, but if there is a flaw in that foundation, the house will eventually collapse. Light as a particle is the foundation upon which this entire structure of theoretical physics rests. It is this very first theory that I take issue with, and for very simple reasons. I've chosen to base my beliefs about light upon my own observations of light, what I see with my own two eyes. When it comes to evaluating different scientific explanations for what I see with my own two eyes, I use my own common sense, which is based upon a very basic principle that most people are familiar with, Occam's razor. It's not a complicated concept, it is about simplicity. In the choice between two different explanations, the more simple explanation is most likely the correct one. If an explanation is built upon several foundations, any single one of those foundations could be wrong, and then that is enough to cause the entire explanation to collapse. The more assumptions used in any one explanation, the greater the possibility of collapse. If you were going to live in a house, don't you want to live in the house with the lowest possibility of collapse? That's Occam's razor, and that is what I base my method of rational thought upon when I look upon the world with my own eyes. You and I have our own eyes, and it's those eyes that allow us to see light, and it is through light that we see the world around us. Just by seeing with our own eyes, we can make some basic observations about light, things we know to be true about it. We see light moving mostly in straight lines, sometimes it doesn't. We see light bouncing off surfaces in predictably geometric ways. These basic observations of light can be explained in terms of particles, but they can also be explained in terms of waves. This is because both particles and waves move in the same basic ways. During the scientific revolution, telescopes were built by people who imagined light to be a wave, and telescopes were built by people who imagined light to be a particle. Not knowing whether light is a particle or a wave didn't stop people from making working telescopes, because telescopes are not based upon what light is. They are based upon how light moves. When it comes to basic observations of light that we see with our own eyes, this is the only one that could be explained in terms of particles. All the other basic observations of light that we see with our eyes cannot be explained in terms of particles, at least not without inventing new concepts that require additional assumptions, ending with complexity rather than simplicity. All the other basic observations of light that we see with our own eyes are more simply explained in terms of waves without the need to invent any new concepts. As discussed earlier, light passes through itself. If light is a wave, that is completely normal because that is how all waves move. This is not how any particles moves, at least not physical ones, because physical particles always collide. To explain how particles of light don't collide, even though they are particles, new concepts need to be invented, and those new concepts require additional assumptions. In regards to simplicity, is not the wave theory the more rational explanation for why light moves through itself? Color is another very basic observation of light that we all share. We don't just see light, we see its color. Even today, color is explained in terms of wavelength. This is a 19th century classical understanding. It was originally explained in terms of the wave theory of light. Light has a wavelength because light is a wave. That was the explanation at the end of the 19th century. Now, in the 21st century, the colors of light that we see with our own eyes are still explained in terms of wavelength, but those wavelengths are no longer explained in terms of waves, and instead explained in terms of particles. To explain the wavelength of light in terms of particles instead of waves, even more concepts need to be invented and more assumptions need to be made because particles don't normally have wavelengths. In regards to simplicity, is not the wave theory the more rational explanation for the wavelengths that explain the colors of light that we see? The last basic observation of light I can think of to notice is that not only does light create heat, but heat also creates light. Walk out into early morning sunshine, and you don't just see the light from the sun and the colorful world it illuminates. You feel its warmth. Flip the light switch in your home, and the electricity flowing through the filament of a light bulb causes it to heat up to a point at which it emits light. We all feel the heat that light makes, and we all see the light that heat makes. We all see that it happens, but the explanation behind how it all happens, how light creates heat, and heat creates light is dependent upon what we understand both light and heat to be. Today, there is an accepted explanation for heat, which seems self-evident. It is explained in terms of vibration and waves. The hotter something is, the more its atoms or molecules are vibrating. This modern understanding of heat was developed in the 19th century classical era. Those waves are not abstract waves, they are physical, through air or some other medium and even solids. Our understanding of heat is part of classical physics because it explains heat in terms of physical motion. Sometimes it is casually mentioned, but there was at one time an alternative theory for heat that competed with our modern understanding. It is referred to as the caloric theory of heat. In this theory, heat is explained in terms of particles. The hotter something is, the more particles it has. This other particle theory of heat didn't just exist. It was at one time in conflict with our now accepted wave explanation of heat. This conflict over whether heat is a particle or a wave didn't just take place. It took place alongside the same conflict over light. These two conflicts over heat and light are treated historically as unrelated, but as you can see, they are completely related because light and heat creates heat. The particle theory of heat didn't just exist, it was based upon the particle theory of light. They are treated as two unrelated conflicts, but really it was a single conflict between two sets of theories. It's easy to explain how light and heat create each other if both heat and light are particles. It is also easy to explain how light and heat create each other if both light and heat are waves. Today, however, we have a mismatch. Between these two sets of theories, we have a mismatch between these two sets of theories. Light is a particle and heat is a wave. The end result is a complicated explanation for something as basic as how we are warmed by sunlight and how light bulbs illuminate our world when sunlight is not around. When it comes to what you and I see with our eyes and what we feel and experience, these represent the totality of the totality of what we can know about light from direct observation of light. While the way we see light moves through space and bounces around can be explained by either theory, only the wave theory can explain how light passes through itself without requiring additional concepts and assumptions. Only the wave theory can explain the colors that we see with our own eyes without additional concepts or assumptions. Only the wave theory can explain how light and heat create each other without additional concepts or assumptions. There are a few additional basic observations of light that can be made, but they require a little more effort than just looking around you with your own eyes and feeling the warmth on your skin. In the early days of this conflict between two opposing theories of light, there was a question about whether light's motion is instantaneous or takes time to move. In the 17th century, with the aid of a fairly primitive telescope and the patience to record distant celestial motions over time, it was first observed and calculated. The understanding that light always moves at a constant speed plays a central role in theoretical physics. But it was an understanding first arrived at and studied through experiment during the classical period, the 19th century. It was first explained in terms of waves. Light always moves at a constant speed because that's how all waves move. Today, the constant speed of light is explained in terms of particles, but to do that requires the addition of more concepts and more assumptions. This is because particles don't normally move at constant speeds. That's only what waves do. They move relative to the medium through which forces moves and has nothing to do with what creates the force. In regards to simplicity, is not the wave theory the more rational explanation for this basic understanding of light's constant speed? There is something that light does, but not all the time, only under certain conditions. Light sometimes creates a visual effect called interference patterns. While they probably occur naturally all over the place and we just don't notice, they were first studied at the beginning of the 19th century in a simple experiment known as the double slit experiment. When most people hear about a double slit experiment, they think about an experiment in theoretical physics that took place early in the 20th century. However, there are two different significant experiments in physics called the double slit experiment. The first one was performed at the beginning of the 19th century. It demonstrates that light makes interference patterns, and those interference patterns were explained in terms of waves. That is why they are called interference patterns in the first place. They are patterns explained by waves interfering with each other. That's what all waves do. Particles don't create interference patterns. Light creates interference patterns when light moves through itself, which is something that waves can do, but particles cannot. To explain the interference patterns that light makes in terms of particles requires many more concepts and assumptions. In regards to simplicity, is not the wave theory the more rational explanation for the pattern that light sometimes makes? In our modern theoretical physics, particle-wave duality states that sometimes light is observed to be a wave, but it is never discussed the ways in which light is actually observed to be a wave. These are the waves. These are the ways. Observing light passing through itself is observing light as a wave, because that's what all waves do and not what particles do. Observing the color of light is observing light as a wave, because color is explained in terms of wavelength, which is something that waves have and particles don't. Observing the constant speed of light is observing light as a wave, because that's how all waves move. Particles can move at any speed. Observing the light interference patterns, observing that light makes interference patterns is observing light as a wave, because that's what all waves do and particles don't. Particle-wave duality says that sometimes light is observed to be a wave, but when it comes to you and I, what we see with our own eyes, that is the only thing we see. No observations of light that we see with our own eyes is explained in terms of particles. To explain these few basic observations of light in terms of particles requires a long list of additional concepts that all require additional assumptions, but no additional concepts or assumptions are required if these basic observations of light are explained in terms of waves. Light moves like all waves move. How all waves move explains everything we observe to be true about light that we see with our own eyes. Our world today is filled with scientific technology that has become so ubiquitous that we give it little thought, but it would have appeared to be something magical 100 years ago. It began with the radio, followed by the television, and today we have smartphones and Wi-Fi. They all transmit through space using invisible light. They all transmit information through space using invisible light, seemingly instantaneous, like magic. It is all wireless technology, and wireless technology was invented in the 19th century classical era. This invention was based upon the wave understanding of light, and even today is still explained in terms of waves, not particles. All this technology demonstrates that light doesn't just look like a wave in a superficial way, as particle wave duality implies. It also functions like all physical waves function. To sum up, everything you and I observe to be true about light with our own eyes tells us that light is a wave. It fits most simply with the understanding of our experience of heat. And the world around us is filled with technology that functions because light is a wave. Despite all that evidence that light is a wave, we are taught to believe that light is a particle that sometimes looks like a wave instead. Does this make sense? I am choosing to base my beliefs about light on what I observe to be true about light with my own eyes. And when I apply the principle of Occam's razor, I come to the conclusion that light is simply a wave and not a particle. Occam's razor is not some obscure concept pulled from the shadows of history. It is the primary logic upon which all of modern physics is based. The scientific revolution was sparked by a new, at the time, understanding of planetary motion, the heliocentric theory, which claims that all planets, including Earth, orbit the sun. This replaced the geocentric theory, which understands all planets and the sun to move around a stationary Earth. Much of a planet's observed motion can be simply explained in terms of geocentric motion. Most of the time, planets move slowly across the night sky like a ball rolls across a floor. But every once in a while, a planet will break from its regular motion and do a quick mini loop, and then continue as if nothing happened. This motion is called retrograde motion, and to explain it in terms of a geocentric model, an additional concept of epicycles was created. Planets are not just orbiting around the Earth, they are orbiting around points in space that are orbiting about the Earth. Over time, more and more epicycles were needed to explain observed planetary motion in terms of a geocentric model. By the time the scientific revolution came along, there were over 50 known epicycles required to accurately explain all planetary motion in terms of a geocentric solar system. That is why the heliocentric theory was popular. It could explain all this observed motion without the need of inventing any new concepts. There are not 50 epicycles, there isn't even one. The existence of epicycles is an illusion caused by the fact that the Earth is not stationary as was assumed. To understand planetary motion relative to the Earth is complicated. To understand planetary motion relative to the sun is simple. This was Occam's razor in action. Isaac Newton is widely considered the greatest scientist in modern physics because he brought about a simplified understanding of the universe. Before Isaac Newton, the universe was split in two, kind of like it is today. Before Isaac Newton, there were two sets of explanations for what happens in the universe. There was a set of explanations for what happens down here on Earth, and a set of explanations for what happens in outer space. There were two sets of explanations because everything down here on Earth was understood to be physical, while everything in outer space was imagined to be immaterial. Physical things and immaterial things move according to different sets of laws. Newton combined these two worlds into one with the bold assertion for the time that the things we see in outer space moving about, the planets, moons, stars, and comets, are physical, like the things down around us, down here on Earth. And rather there being two separate sets of explanations, a single set of laws explains the motion of all of it. Newton combined two into one. He combined the heavens and Earth into a single understanding. This was Occam's razor in action. As Carl Sagan eloquently put it, we are made of star stuff. Occam's razor is also the logic that drives the development of our modern understanding of electromagnetism. At the beginning of the 19th century, light, electricity, and magnetism were all thought to be separate, unrelated phenomena, each with their own unique set of laws of motion. But by the end of that century, James Maxwell combined them all into a single understanding of electromagnetism with a single set of laws and mathematical equations that explained all of it. This was Occam's razor once again in action. While this is a well-known story of unification and simplification, which is acknowledged to be a great step forward in scientific understanding, no one pays much attention to the fact that, for Maxwell, light waves were physical and not abstract, as we are taught to believe they are today. Not only was light understood to be a physical wave, it played a central role in his entire theory. It is what unified everything. There is one additional way light, as a wave, simplifies our understanding of the universe, and it is very basic. Sound that we hear with our own two ears is also a wave. If light is a wave, then light and sound have the same explanation. Just as tones of sound are explained in terms of wavelength, so too are the colors of light. Just as the loudness of sound is explained in terms of wave amplitude, so too is the brightness of light. Just as sound moves at a constant speed, so too does light. Sound is an invisible force that moves through space, but it is a physical force, and so is light. Newton simplified our understanding of the universe when he realized that the force that explains why things here on Earth fall to the ground, gravity, also explains why planets orbit the sun and moons orbit planets. Two things that seem unrelated are explained in a similar way. Understanding light as a wave does the same thing. Light and sound may seem unrelated, but they are explained the same way. They are both physical forces carried by physical waves that move like all physical waves move. Simplification drove our modern understanding of planetary motion in the universe. Simplification drove our modern understanding of electromagnetism, but simplification has clearly not driven our understanding of light. Beginning with the scientific revolution up until the end of the 19th century, Occam's razor was the driving force in the development of scientific understanding. Then, in the 20th century, with the switch from a simple physical wave understanding of light to a complicated immaterial particle understanding, scientific theory has been heading in the opposite direction ever since. With each new expansion of quote-unquote knowledge comes an endless sea of new concepts and additional assumptions. Complexity is layered upon complexity to the point that logic and reason have been completely abandoned. For example, according to theoretical physics, in the quantum world, things don't even have to make any logical sense whatsoever, and the explanation for why things make no sense is because quantum particles are immaterial. Physical particles have to make logical sense, but immaterial particles are not bound by our earthly logic and reason. Before the scientific revolution, everyone was so sure that epicycles explained planetary motion, but it turned out to all be an illusion because the geocentric theory was a house built upon a flawed foundation, that the Earth is stationary. I think theoretical physics is like that, a house built upon flawed foundations, because based upon what I see with my own eyes, light is not a particle that sometimes looks like a wave. It is a wave. There are not two halves to physics. There is only physics. Theoretical physics is an illusion caused by flawed foundations that light is a particle. The Emperor wears no clothes. Behind the booming voice of Oz, there is a very small, frail, old man. End of part 1.